Welcome back. Happy to be back. Missed y'all. Hope y'all had a wonderful time.
Nope.
Now, heart-to-heart time.
Nope. I'll practice, bro. Love you.
Actually, y'all did pretty well in the quiz.
I got a 47.
I was not mad at all. All right, so ladies and gentlemen, we have reached the part in this class where I want to make sure and bring your awareness to. We are getting out of the easy stuff. We have a couple ways. You'll find out what I mean. We are getting out of the easy stuff once we leave talking about these bonds, and you will start the second semester off with nomenclature. Which is why we're having this talk. You need to bring your A game. We are on a great course. We're on a great schedule right now. We're rolling right along. Which means we're going to cover stuff, probably going to cover stuff that I didn't even plan on covering, which is awesome.
Question. Is this the part of chemistry where I convince myself that I don't want to do chemistry for the rest of my life?
I'm about to say a whole lot of things.
Sure. I will look at you and tell you nomenclature is the one thing, and I email all your parents and tell them, bless you. Nomenclature is the one thing everybody fails.
Love it.
In my whole teaching career, I've had 2 kids pass. First one passed the first quiz with a D, and then they failed the second one. The second kid failed the first quiz, and then passed the second one with a D.
Oh, so nobody's ever gotten an A on this. Okay.
On nomenclature, never.
Whack. Maddie, you got this.
You're challenging me.
This makes me So whenever I look at you and I tell you that those that walk across the stage as a valedictorian has failed something in my class, I'm telling you the truth. They have failed something in my class. So, best of luck. Besides that, let's keep rolling with this. We're going to get you guys to finish off this first semester on a high note. That's the goal. This next quiz is one of those easy quizzes. Just knock it out of the park, have no issues, have no problems. We're going to start from the very beginning with Lewis structures, because let's be honest, nobody in this room probably has the slightest idea right now what you're doing. Okay? And that's okay.
I mean,
Because we had a break.
sort of, but not really.
And some of us had the flu. If you get the flu, do not come to school.
Can't make me promise.
You'll leave the school with a paper and work on
Alright, so in this, I've left up the rules for the Lewis structures, but in this, we're going to start from the very beginning with it. So within this, let's get it rolling. And
report to the office.
let's go.
Yes. That one.
Where's that one at now?
What
I'm literally having to pick something out of my head.
What number is this?
What number is
I can't shake this one, so we're going to do carbon dioxide.
it?
Carbon dioxide, CO2. I'm going to leave the rules over on the left. I'll leave them there for today. Tomorrow you probably come here, they'll be gone. You need to be able to apply these without seeing them. So first thing you must always do is you want to find your center atom. It's the one with the lowest electronegativity, but it is never hydrogen. So in this case, lowest electronegativity is carbon. Carbon goes in the center. So we literally just draw carbon. Step 2, draw the skeleton, give all atoms a full octet when required. So in this, draw the skeleton, puts a single bond with the other atoms in there, so oxygen, and now we're going to give everything a full octet. Within this, remember, these dashes, those are bonds. These represent 2 electrons. So in it, all of them are wanting 8, except for those that break the rule. And in this case, oxygen wants 8. It has a bond to it, so it already has 2. So it needs 6 electrons. But remember, when we do these in things called lone pairs. So they're pairs, like the shoes on your feet. So divide them by 2 gives me 3. I need 3 lone pairs. 1, 2, 3. This oxygen over here is the same setup. It's the same thing. It wants 8. Has 2 because of this bond. Gives me 6. So 3 lone pairs.
The fact that you changed how you wrote your 2 is bothering me.
Oh no, don't bring it up.
But it's okay, Mr. Hall, you can leave it how it is. It doesn't bother me that bit though. No, you changed the wrong one.
Better?
Oh no, God no, Connor.
What have I done?
Erase it all.
Better? Oh, you stopped with that too. Sorry.
What?
No, there's multiple different ways to spell 2. There we go across the curriculum in this class. Welcome back, ladies and gentlemen.
I literally didn't even realize you were spelling 2. I thought you were doing like plus and like a little
Infinity.
dot. That's why I was like, there's only 1 there. That doesn't make any sense.
I'm so confused.
See, this is what I mean by our brains work in puzzles.
It's true. Alright, carbon. Carbon wants 8, but in this case,
It has
has 2 bonds with it, which means 4. So it needs 4. This gives me 2 lone pairs. There's 1. There's 2.
no, that's it.
But
It needs 2
can't
more.
go over a certain number.
Correct.
Okay.
You do not want to go past 8. Because that breaks the octet rule. Unless you're sulfur or phosphorus
Yeah.
with oxygen, chlorine, or fluorine bonded to it.
Whack.
Number 3. Calculate number of electrons. Hashtag of E minus. You must show. In this case, remember how you do this. When you're calculating the number of electrons you got to show, you're referring back to your periodic table and those valence electrons. Because in these Lewis structures, all we care about are showing these valence electrons. So we got carbon and we got oxygen. We got 1 carbon. We have 2 oxygen. Mr. Hall, where'd you get that from? I got it from right up here. 1 carbon, 2 oxygen.
How
In
many
it-
days?
In this case, carbon, there's 1 of them, but for every carbon I have 4 valence electrons. How do you get that?
On the periodic table of elements.
From the periodic table of
Because
elements,
carbon
it's
is in the 14th column.
carbon in the 14th column. 14th column has 4 valence electrons. That's referring back to stuff that we've thrown out there before. Oxygen, how many valence electrons?
6.
6.
It's in the 16th column.
The 16th column. 16th column has 6 valence electrons.
Yes.
So 1 times 4 is 4. Why? Because math. Oxygen, 2 times 6, 12. Why?
Science.
Math.
Wait a
STEM.
second.
This is STEM, Mr. Hall. We got the technology, the science.
Hey,
math.
here we go.
Now where's the engineering?
So 4 plus 12, 16. All right. We can only show 16 electrons. That is it.
Really?
You cannot show more than 16.
We have too many.
This is, look at you. I'm so proud of you. Hold your horses. You're jumping ahead of me. I haven't even got to step 4 yet. So we can only show 16. 16 is the limit.
No, I was taking that question.
Step 4. Count hashtag of E minus showing.
I knew so.
Count the number of electrons showing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
We can count. So 20.
Does anybody in this room right now not see how I got 20?
I see. I think.
I can see clearly now.
Remember the bonds. The bonds count as 2 electrons. Do not forget to count your bonds. So we're showing 20. Well, snap. We got a problem.
Mr. Hall, I have 20.
Make it equal signs.
So in this, add double, triple bonds where needed to fix number of electrons showing. Resonance when applies.
Yeah.
So in this case, we're going to add double and triple bonds. So let's start
Because they
here.
really like each other.
Just because I want to start there.
Okay.
We put another bond here. Remember Mr. Hall's rule. Once you put the bond there, make sure and erase lone pairs off the 2 atoms you just put the bond between.
Boom.
So I put a bond on this oxygen.
Erase that one.
I erase.
Does it matter which one
As of right now, no.
But once we learn more about whatever
But you learn about Vesper.
Vesper, that thing. I remember you saying
Valence shell, electron pair repulsion.
Wow.
What?
Vesper?
Valence shell
Electron pair repulsion.
Oh.
seepers.
Alright, in this case, do not forget, you also got carbon here. You have to erase one off of. The reason you're doing that is because if you don't, then you will break the octet rule.
The sound that my mouth does.
Alright, in this case, how many electrons are we showing now? Snap! We still got a problem.
Put another equal sign.
Add another double bond.
Now,
Or add another.
before we jump off here, you're right, we're going to throw it over on the other side. But before we do that, I want to show you what's the purpose. Why do you try to go for symmetry as much as possible? And I'm going to show you as to why, and it applies right here in the 6th.
Because without symmetry, your OCD is all whack.
No. I mean, technically, if you look at it, that is symmetrical.
Okay, so in this case, actually, let's add a triple.
God.
Let's add a triple bond here instead of wanting to add that double bond over there.
You can't.
Once you do that,
You break the octet rule. Oh, no, you don't. Never mind.
so can I fix that?
Sure, yeah.
Erase those.
Erase
Wow.
Erase those. Am I breaking the octet rule now?
No.
No, because look, carbon has 4 bonds. So 4 times 2 is 8. Oxygen,
That would make
Yeah, but
6
then
for the
you would
bonds,
just
lone
have
pair
to
gives
do
you 8.
more work to do the arrows thingy to make it symmetrical.
Resonance structure.
Wouldn't that make one side harder?
Which is going to lead me to where I want to go.
It's all out of whack.
In this, is there anything wrong with this loop structure?
I mean,
The electron up pair needs to come over here.
That does bother me. It's true. I'm going to do it just because I'm OCD about it. But when you're looking at it, am I showing 16 electrons? Sorry. Am I showing 16s?
yes.
Yes.
It looks like a sideways man.
Okay. So in this, what's left to do?
With a big old bed.
Vitamin half, number step 6. Properly check charge to make sure they match. This is the thing. Split the bonds in half. You're doing this mentally.
You're doing that literally.
So you can see it.
Yep. Because it's purple and it's important.
And this is where it comes in at. Okay? Because we'll start with this oxygen here. Take the number of valence electrons they normally have. Oxygen normally has 6 because it's in the 16th column.
Yes.
Subtract from it the number it has now. 1, 2, 3, 4, 5, 6, 7. So that gives me a -1 charge.
Quick math.
That oxygen has a negative charge now. Okay, look at carbon. Carbon normally has 4.
That has 4.
14th column. In this case, 1, 2, 3, 4 has 4, so it's 0, so it's neutral. That's cool.
Quick math.
Then over here on this oxygen, normally has 6. Subtract out 1, 2, 3, 4, 5. So that one has a positive charge. In this case, these cancel out to give me the same charge I got up there. But whenever you're doing these, you're trying to get it as symmetrical and you're trying to get it without charges as much as possible. In this case, can you do something different here to
Yeah.
get rid of these charges?
Yes, sir.
Would you add a double bond and then take the lone pair off the carbon?
So add a double bond here. If we add the double bond there, we take that lone pair off and take that lone pair off. Am I showing the proper number of electrons?
Yes, sir.
Sure
I'm
are.
showing the 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Oh, man, and look at that, it's all neutral.
Yay for neutral. Was it Switzerland? Did they stay neutral?
Yes.
They don't want to be an ally.
Do you know why they don't want to be in anything? Because they house the
Because they're
majority.
scared.
No, because they house the majority of the world's money. If they went to war, the entire world would collapse.
Good.
No, not good. their entire country is rigged to blow up.
Yeah, why is it getting kind of tacky?
There's only one way to invade their country.
Okay, so in this, looking at everything, we're still going to check the charges just to be safe. Start with 6 because we're looking at oxygen, minus, I'm showing 1, 2, 3, 4, 5, 6, 0. Neutral. Nothing there. Carbon normally has 4, 4 minus 1, 2, 3, 4. Neutral. Good. Oxygen here normally has 6, 1, 2, 3, 4, 5, 6, showing 6. Booyah. Everything's neutral. Now remember,
Snap cracker.
what Mr. Hall said before, because I know you've all forgotten. You do not give me the split dashes with the electrons out to the side.
Wrong.
That is not the proper Lewis structure.
Get
I
that.
feel good about this. It's only a matter of time before you're in
What?
What is that smile?
Yeah, I've always been at a nursing home over the winter break. There was an old guy that gave me
What's that? Only time I got,
What I promise you before break.
This old guy tried to take a list of them.
Let's just stop. Stop right there.
He did. He tried to take a
Alright, anyway, so here is your proper Lewis structure for carbon dioxide. Alright?
Whack.
Now, you've seen resonance. I've shown you resonance before. Time we got.
I just want to do more of these, Mr.
do
Hall.
we have to?
Because those ones
say
you
it's
gave us
neutral?
the other day were whack.
Alright,
Wait, no we don't, because it's not positive resonance.
there's only so far you can take this being simple. Then there comes a point in time to where it's time to put some steroids in.
No. That's illegal, Mr. Hall.
Roy
Ladies and
Rage.
gentlemen, that comes today.
Is that the things they have on the side of like mouthwash? Like, are those Lewis structures? How do I call those? I just want to know why they put it on mouthwash.
I have no idea what you're talking about.
I bring it, but like that's kind of weird.
No, then they say
All right.
an illegal substance and track.
Here we go. Let me introduce to you your worst nightmare.
It's the Lewis structure on roid rage. Yes,
Ba,
we
ba,
love her.
ba,
I just saw you
What?
at the house.
She is a true queen.
Here comes your worst nightmare.
Why?
It's positive. You have to make it positive. Wow.
There is a charge. Once you get a charge, Mr. Hall is trying to trick you.
Whack.
I'm openly letting you know this right now. I'm trying to trick you.
Ooh, Mr. Hall, I know whether there's a charge.
Actually, I don't really, honestly, but I mean, I have an idea if I think whether it's a church.
Okay?
Anyway, keep going.
Let's keep her on this session.
My goal is to trick you. Your goal is not to be tricked.
Well-
Guess what you do?
Oh, wow.
Follow
Why
the
did I think of
steps,
that?
and there's going to be one thing that changes for you. One thing.
One thing.
You'll love this.
I know whether.
So in this, let's start. Let's go through the steps. Step 1, find the center atom. What's the center atom?
Hydrogen.
How do you know it's nitrogen?
Because hydrogen is never the center.
Why can it not be hydrogen?
Because it only forms one bond.
Yeah, I can't.
Only forming one bond will not make it full octet.
Yeah. That's
Okay? Alright, step 2, draw skeleton. Give all atoms full octet where required.
Why does this remind me of like the numbers?
Hey, can I stress something to y'all right now? For some reason, for the last 2 years, I've used this. This is ammonium. Yeah.
This is what
Hydrogen can't.
exactly. That's why it's a positive
That's it. You
charge.
just said like that.
Hydrogen will not form anything besides one bond. And for years, I've given this. And for years, I have kids that go in here and do this. I literally want to take their quiz and rip it. I'm openly telling you.
Just give me a McDonald's application.
Whoa, bro.
Like your college.
You're not an organic too.
You still have to go.
Yeah, they require a high school diploma.
Alright, in this, hydrogen only forms one bond, so now the hydrogens are stable. Nitrogen, does it have a full octet? Yes, it has a full octet because it has 4 bonds. Now in this, you've got the full octet, you've got the skeleton, stop, move on to step 3. Calculate the number of electrons you must show. I will look at you and tell you, 3 is where the change is. Calculate this up. We got nitrogen and hydrogen. We have 1 nitrogen. We have 4 hydrogen. How many valence electrons per nitrogen? 5. So 5. How many valence electrons per hydrogen?
1, bro.
1. We get that? Why does nitrogen have 5 valence electrons?
Because it's in the
15th column.
15th column. Mr.
Hydrogen
Hall.
has 1 because it's in the first column.
Science.
So 4 times 1 is 4.
9.
So we get 9. But here's the thing. Here's where the change comes in place. Take the charge into account here.
Whack.
How?
There is 8 because there's a positive charge, which means you have lost an electron.
Wow.
Because you've lost a negative charge.
Or, hear me out. I don't care.
Couldn't shower be Oh my god.
So you are to show 8 electrons.
I want to go to Mr. Hall.
So So that's not the way.
Mr. I have something for you.
Is this right? I'll ask you.
Yes, no, you got the plus sign next to nitrogen.
PhD. I'm just trying to live, man.
You have to show that nitrogen is positively charged.
You have to show that nitrogen has this positive charge. Look at nitrogen. Nitrogen normally has how many valence electrons? 5.
How many?
Minus, how many does it have right now? Remember, mentally, split the bond, electrons come off to the sides. So 4, 5 minus 4 is plus 1. So nitrogen has a positive charge.
Wait, how far?
See?
So it all comes down to.
Where
I'll
that
tell you,
positive
Miss
goes.
Cole is literally the
No.
best at quick math.
For real.
She would look at that and be like, all you gotta do is put a plus sign above the end. That's it.
No.
That's all we take is
How
wrong.
much of
Because we're in her class and she's like, okay, what's 172 divided 7,500? And then she's like, all right, kids, like 5 seconds later. She's like, all right, kids, this should have been your answer. And we're like, no, huh?
I'm still setting up the division.
yeah.
How do
All right.
how do
I'm
you
still
do
writing this out.
the electrons in this?
Here's the thing. This right here is what we call a polyatomic ion.
Is there any
No.
No, I've got the point where I just like make sure.
Got
I
charge?
write it down.
Must have charge. So polyatomic ion. Here's what polyatomic ions are. Group
She'll be like -5 and I have like
of covalent. Bonded atoms that have ionic bond characteristics. I'm going to look at you and tell you, tomorrow when you walk in here, I'm going to give you a list.
Of polyatomic.
the list.
Here is the list. First off, do not have a heart attack. This column's the same as the other column. They're the same, they're just in different order. Okay?
What is
And you
that?
do not have to memorize all of these. I am going to tell you your next quiz in this class will come next week, and this will be it. I will ask you for the name of the polyatomic, or I'll ask you for the chemical formula. This is where everybody struggles. That charge is part of it. If you do not get the charge right, you did not get the polyatomic right. And I will make sure you know your charge.
Is it like a
Because this comes into play in nomenclature.
when? What was that?
No, we don't.
What if just hear me out here? What if they just went missing?
The list,
Yeah.
I would just open up
Nope. What if
My
they
No,
boy
what if that
missing?
bit went missing?
What if
Like,
it like
My boy-
missing?
what if it went like
Miss.
it had a rough time with the mafia missing? Like it went missing.
Like your eyebrow missing?
Okay.
I guess we'll go.
Tough.
I found out. too.
Wow. That's tough.
All right.
I saw the opportunity. I did. I'm sorry.
So let's break in, because these polyatomics is when life gets interesting. Let's break it in with something that your class wanted to do a while ago. Oh, that's perfect.
At least you weren't like firm and like this. You went firm both of that.
I don't do that.
He said, what am I?
CO3
Carbon dioxide.
is carbon trioxide.
Alright.
You make me want to like go to my eyebrows.
CO3 2 negative is carbonate. Big difference.
Carbonated one.
So in this, I want the proper Lewis structure for carbonate. I'm going to give you a moment to give it a shot.
How did you say it again?
Carbonate.
Is that just all it is?
Yeah, that's it.
Carbonate.
That's it.
Do you mean like carbonation? That is what
Nope.
carbonation
Carbonate.
Boy.
Carbonation is just carbon dioxide
Yeah. It's
dissolved and pressurized within your soft drinks.
Now what?
Okay. Before C is my center because science.
The varsity cheerleaders are excused at this time.
Is it minus or the negatives and behind the two?
Yes, it matters.
Okay.
Because this will show the charge. Like later on, you'll learn about oxidation and reduction states, and that's when the charge goes down. It's a dead giveaway to let us know the differences.
You got one of these things. You're supposed to show 4. Quick. 4. That is 6. Wait a minute. There we go.
Give this
Bill
a
Color
shot.
into the office. Bill Color.
Do not just assume you can do this. This is not simplistic in nature.
Yes, I see this now.
Can I just completely cut one off?
Full octave.
Nope.
But carbon can't have more than 8.
Full
Okay.
octet, Maddie. Just do it. Renee.
At this time, the boys' basketball team has been released, and we would like to wish them and the girls the best of luck today.
How'd they go get their education, man?
Quick maths, Mr. Hall. But I don't know what I did and how I did it. Wait a minute. Nope, that's not this piece. So like, hold on. Hey, let's just step in. That's what I have
Some.
so far. What am I missing?
Very close. Very close.
I'm showing the right number of electrons. I think. I mean, I'm pretty sure I'm supposed to show like 24, and I think I'm showing like 24. I think. In my brain.
No.
Wait on my timer.
Maddie, see what you got?
Where'd you get 24 from? Yeah, but that told me that it took you to negative 20.
I was gonna ask Trent.
But I have.
Symmetry, Maddie. Symmetry.
Did an Alyssa get it?
Close.
Have you showed him?
See, exactly. But I don't know where to put that.
Don't you need, wait,
You just do this go. Everything is a freaking negative. This is how negative you won't get. Wait, Mr. Hall. Okay, so the carbon is, it's showing 4 more electrons than what it needs. And each of the oxygens are showing 2 more electrons than what they need. So add the oxygens together, you get -6. And carbon, and then, yeah, and then you end up with -2.
He just said it then. Yeah.
He literally just came up with a way of just figuring out something or another.
Yes.
Alright, here we go.
In my head it made sense.
If you did not get this, do not feel bad. This was a complex one, but I'm giving it to you to see where you're at. So in this, I already did the first 2 steps. Step 1, find the center atom. The center atom is carbon. Why? Because it has the lowest electronegativity between it and oxygen.
Yes.
Step 2, draw the skeleton. Give all atoms a full octet when required. Let's give a full octet. At this point, you should be able to notice when something needs a full octet and be able to give it a full octet as I just did. You should be good to that point. From here, calculate the number of electrons it must show. So I have carbon, I have oxygen, I have 1 carbon, 1 carbonate, and I have 3 oxygens. There's 4 valence electrons per carbon because it's in the 14th column.
16.
And then there is 6 valence electrons per oxygen.
Because it's in the
16th column, so 3 times 6 is
You get some.
18 plus 4,
Quick math, 22.
22. I've got to ask Miss Cole about this quick math.
It's whack.
I've never heard
It's
of this.
so.
Wait.
Now, look. Don't get tricked up. You have a charge. Take the charge into account here. You have a -2 charge. Electrons are negative charged, which means you picked up more negative charges, means we picked up more electrons, and we picked up 2 of them. So plus 2, 24. So we are to show 24 electrons. Let's count up how many we're showing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.